Hey everybody, and welcome back to the 7th lesson on linear relations. Today we are going to be using graphs to estimate values. So we're going to be looking at a couple different terms today and then looking at finding values based off of the graphs that we have. So the first term that we're going to be looking at is interpolation. Now interpolation is the process of estimating values between the data points on the graph. So that means we're going to be looking at data points that are within what we have graphed. For example, 1 here, it says using interpolation to solve problems. So Jenna borrows money from her parents for a school trip. She repays the loan by making regular weekly payments. The graph shows how the money is repaid over time. The data are discrete because payments are made only every week. So that just means they've only plotted the points that have been paid every week. So not in between. She doesn't pay partially between, just every week. So that's why it's called discrete. Now the thing we want to look for first is how much money did Jenna originally borrow? Well, if we don't have the information in the paragraph or the introduction here, we have to look down at the graph. Well, your first thing is, if we look at 0, so right here, we want to look at, well, how much money was she borrowing at that point? The money owed is on your left here, going vertically, and it says that she owes $200 at the time of 0 weeks. So that means she borrowed $200 at the beginning. So part A is done here. How much money did Jenna originally borrow? $200. Now we're at part B. So how much money does she still owe after 3 weeks? Well, we go back to our graph here, and time is across the bottom, so our X, and we're going to look at 3 weeks here. So that's the 3rd week. Now, we don't have a nice line here yet, but I'm going to make one for us. Now that we have our line connecting all the dots, we're able to go right up from our 3-week marker and find exactly how much money she owes. So we're going up from right here, and I'm going to use a tool to help me out, but what you would be doing is you'd be drawing a line right up from your 3 weeks, and you'd be going straight up to where you hit the line, and then you want to come across, and it'll tell us exactly how much she owes. Well, she's falling in between 120 and 160, so that means that that line there is going to be $140 that she owes at that time. So at 3 weeks, she owes $140. And we move back up here and we just write down that she owes $140 at that time. The third question that we have here is how many weeks will it take Jenna to repay half of the money that she has borrowed? Well, she borrowed $200. So $200 is how much she borrowed, divided by 2 will get us half. So she owes $100. Or how long will it take her to repay $100? Now, we want to go back to our graph here, and I'm going to be using this tool again, but this time, instead of starting at the bottom on my X, I'm going to be starting on my Y. So I'm going to find the $100, I'm going to move over, and then I'm going to go down onto the X. It actually happens to be a point that we have plotted out already. So when she owes $100, so she's paid half of the money back, she's at 5 weeks. So it's going to take 5 weeks. Now, because I'm doing this on my surface, I have a couple other options for my shapes, but especially when you are working on any assignments, even when you're working on your accountability check, if you are using Word, you can go under shapes and you can select this line tool or lines with arrows, and that'll give you the option of creating your lines on the graph. So you don't have to print out the documents every time. You can add to the graphs that way and show your lines. And it does help if you color code it so I know exactly what line goes to what question. Now, the second term that we're going to be looking at is extrapolation. Extrapolation is the process of estimating values beyond data points on the graph. So outside of what we have, we want to continue our graph so that we can find the value that we're looking for. In example 2 here, using extrapolation to solve problems. Maya jogs on a running track. This graph shows how far she jogs in 10 minutes. Assume Maya continues to jog at the same average speed. Using the graph for part A, predict how long it will take Maya to jog 1,350 meters. B, predict how far Maya will jog in 14 minutes. And C, what assumptions did you make? So the first part we're looking at is to predict how long it will take Maya to jog 1,350 meters. Now you can see that our graph only goes up to 1,200 and our time only goes up to 10 minutes. So we're going to assume that this is a linear relation and our line is going to stretch out straight. So what I'm going to do is I'm going to start with my point back here. Now I'm just going to line this up, get it right on your line. Now, if you have it right at the very beginning, you want to overlap that line so you can see exactly where that point is going to be or where that line is extending to. Once you have that line completely covered, you can let that go. And that's going to be our extrapolated line here. It's extended beyond what we were measuring. Now our next thing is we want to continue on the x and the y for the values that we are increasing by. So if we look at the bottom here, it was increasing by 2 every line. So this would be 12, 14, 16, 18, 20. On the y, we're going up by 200 every line. So this will be 1400, 1600, 18, and 2000 should be good enough for right now. If we need to take it further, we can. So expanding back out to look at our graph. Now, what was our question again? Well, we wanted to know how long it took to jog 1,350 meters. So we're going to look back to the graph, and I'm going to take out my tool. And we want to find 1,350 meters. Well, each line is 200. So we're going to fall right in between would be 1,300 and then a quarter way through. So we're looking at 3/4 of the way up would be approximately where 1,350 would be. Now, this is just a prediction, it's just an estimate. This isn't calculating the exact value. So as long as we're in the general area, we should be close to what our answer should be. So we go back down And we can find that we're between 10 and 12. No, we're not right in the middle where 11 would be. We're a little bit further. We're 3/4 of the way as well. So we'd be closer to 11.5 minutes. So our prediction for her to jog 1,350 meters would be approximately 11.5 minutes. For B here, it says predict how far Maya will jog in 14 minutes. So I go back down to my graph. Now I'm going to choose a different color this time. I'm going to choose my shape. Again, I'm going to use my right angle here. And I want to know for 14 minutes. So from 14 minutes, I'll go right on, go up from there, connect to my line, and I want to go right over to my Y. So that's about right on. Now, each spot or each line on the left hand side is going up by 200. Now, it's not right in the middle, which would be 1,700. So we can estimate that it's going to be close to 1,650 meters. So for 14 minutes of jogging, she's going to travel 1,650 meters. The last part here says, what assumptions did you make? Well, the assumptions that we made was that Maya will continue to run at the same pace. She's not going to get tired. She's going to continue through at the exact same pace, which means she's traveling at the same meters per minute. So that Maya will continue to run at the same pace, so the same meters per minute. And that'll finish us off for part C for this question here. Now we're assuming that because we are working with linear relations, so it makes the most sense with what we're working with right now. Example 3, we are looking at interpolating and extrapolating to determine values of variables from a graph. So use the graph of a linear relation. Determine the value for x when y is 3. Determine the value of y when x is 5. So this is the graph that we're going to be looking at. It's going from 0 all the way up to 8. Now we want to look inside of the data that we have, and we also want to look outside of the data that we have. So the first one that we are looking at is y equals 3. So when y equals 3, now if we extend this way, we're not going to find any data collected. Now, if this is a linear relation, it's going to make a line similar to that. So we know we want to go to the left to find our point that we're going to meet with. So we're going to be extrapolating this and creating a proper line now so that we can see exactly what it's going to look like. So I'm going to open up my shapes again. I'm going to be creating a line. Same as I did last time. I want to start right on top of it, and I want to continue that line so that you're completely covering that line so that you know you're right on the same slope as what the line should be. Now we can go back to my tool. I want to use my right angle tool, and I'm going to be going from y of 3. Hold on, doesn't want to cooperate. I'm just going to extend that down. So a y of 3, and now I'm going to stretch this out to see where I make contact with the line. So it's just past -5 there. So it's pretty close to the middle of -6 and -5. So I'm going to estimate that when y is 3, our x value is approximately, now I use this squiggle line to mean approximately -5.5. The next one we want to look at is determine the value for y when x is 5. So I'm going to just choose a different color here. I'll go back to green. Same shape tool. I'm going to use my right angle. So I want to look at when when x is 5. So I'm going to go over to x where it's 5, go up from there, and I want to find out approximately what my y is going to be. So that looks pretty right on. Now, I'm falling in between 6 and 7, but I'm closer to that 7. I'm about 3/4 of the way there-ish. I'm just over halfway. So if you said that you're approximately either 6.6 or 6.7, you'd be close to right on. So that one was looking at interpolation because we were looking inside the data that we had. And the first one, A, was looking at extrapolation because we were looking outside of the data that we had. Now for example 4. The city has grown over the past few years. This table shows how the volume of water used each month is related to the population. So the population starts out at 100,000, and in the table here goes up to 220,000. The monthly water starts out at 750 and goes up to 1,650. So it says to graph the data above and use the graph to, and then there's 3 different parts. So the first thing we need to do is graph the data. Now I'm going to use my population across the bottom as my x value and my monthly water usage across vertically, which will be my y value. Now to make all this fit on the paper, I have to choose a value that's going to increase by a certain amount so that we can actually make this all fit. 100,000 people is where our table starts. Now I'm just going to choose to go up by 20,000 each time. So each line would be 20,000. Just so that this doesn't get too congested, I'm going to skip the middle one here, and I'm going to do 140,000, 180,000, 220,000, 260,000, and that should be enough on our x. Then we have to start out at, well, our minimum value is 750 for our monthly water usage. So if we start out at the bottom just at 700, and we can go up by 100 each time. So 800, 900, 1,000, and so on. And you can just label it all the way up. Now you could skip in between if you like, just so it doesn't get too congested. Perfect. Now we have our y-axis labeled, and we can start looking at graphing. Well, our first point that we need to graph is when the population is at 100,000, our monthly water usage is at 750. So between 700 and 800 would be right in the middle here, is our first point that we're going to plot. The second point that we want to plot is at 130,000 people, it is 975. So at 130, well, that's going to be approximately right here. We're going to move up from there. So moving up, we're going to find 975. So right approximately there. Get rid of those lines. Next one that we're looking at is the population of 180,000 and the monthly water usage of 1,350. So at 180,000, we're moving up to 1,350. So approximately right there. It should be right in between the middle of 1,300 and 1,400. Our last point that we have to plot is at 220,000 people, the monthly water usage was 1,650. So at 220,000, we're moving up to 1,650. So right there. Now we should have made a linear relation, so our line should go right through our points here. So we can see how close we were by plotting this out. So I start at my first point here. I'm going to go out and I'm going to extrapolate it so that I can use the data. And that's not too far off. My points are pretty much right on. So that's perfect. Now that we have that graphed, it says to estimate the monthly water usage for a population of 150,000 people. So 150,000 people, I'm going to choose a different color here. Go back to my shapes. 150,000 people. So I'm going to take out my shape tool again. I'm going to find on the graph, on the X, where my 150,000 would be. So 150,000 is going to be right here in the middle, going up from there, and right there. Extend that across. Now, looking at that, I could say that we're approximately at 1,130. We're not quite in the middle, maybe 1,140. We're not quite in the middle, but we're really close to the middle. And again, it says to do an estimate. So when we did our estimate, we're at approximately 1,100 and let's say 30 ml. Next one, it says to estimate the population when the monthly water usage is 1,400 mLs. So 1,400 mLs. Now I'm going to choose a different color here. We'll go green this time. Find my shape again. Move over to 1,400. And we'll go out from 1,400. And we'll adjust this and move down to my X. And approximately right there. So it's between 180,000 and 190,000 or 200,000, and we're falling pretty much right in the middle. So we'd be at approximately 190,000, and we're talking about people. Don't forget your units. For C, it says predict the water usage for 250,000 people. Now our last one here is we have to go down to where, well, 250,000 would be found right in the middle there. Go with yellow this time. Use my tool again. And if you don't have this tool, you'd just be using a ruler. Just get this right on our spot, right in the middle. Moving up from 250,000 people. And where it touches the line right there, extended over to my y, which is right about there. So to me, that looks like it's, well, close to 1,875. So approximately 1,875, and it'll be ml for our units. So that's looking at interpolation and extrapolation for this unit. So looking within the data that we have and looking outside of the data we have. Now, you can remember create these lines that I was doing in your Microsoft Word. So you should be able to complete all the assignments now digitally in case you weren't doing that already. If you are having any issues with creating those lines or finding exactly what to do digitally, just send me a message and I can go through that with you.